There we go. All right, let's just talk a little bit about that. So you're talking about why would you write code in like C# or Java or something versus JavaScript if you're writing it for the web and JavaScript runs in the web browser. And we'll definitely talk about this more in one of our classes to make sure that people understand the distinction, because it's one of the ones that some people already understand and a lot of people don't, and it creates confusion when you start building stuff in a web browser. But you actually have code that can run in two different places. I could probably, let me see if I can steal somebody's set of slides here that I'm familiar with. Let me see. I got some floating around here from Girls Develop It that might explain this.
I was just like, I don't know, I've seen like websites created with .NET and C#.
Right. So this is, oh, I'm not broadcasting to you guys. All right. Some of these slides, let's get this up on the screen up there, hopefully. So I don't know how this is going to go because I'm pulling these slides, but this is, oh, come on, work. Don't be all quirky like this today. You can do it. All right, maybe I'll change to one of these other connectors, not this one. Let's try one of these. Maybe it's this HDMI connector that's all wonky. Come on. Oh, wrong way. Let's try this. Please work, please work. Cross my fingers. It's not looking very promising. Oh, wait. It does look promising on here. There we go. All right, so let's, yeah. I haven't looked at all these slides recently, so we're just gonna see if these help me talk about this topic a little bit. But you're talking about C# versus JavaScript, writing web code in C#. So when you visit a website, or the way where places code can run is these clients are like your end computer, so that's your laptop and the web browser in it, and the server is the computer sending you code. And when you write C# code, because your browser, the web browser, really only understands one language, which is JavaScript. That's pretty much the only thing it can run. Barring, I think Microsoft's web browsers can still read like VB script, and there are some other languages that are being tested. Then you can't run C# inside of your web browser, your client. So any C# code that's used, or any other language, Java, Python, any of these other languages that are used for web development, Ruby, those run on the server, and then they generate the content, which is usually HTML and CSS if needed, or any other data that needs to be sent up, and send those up to your computer. And then your browser on your computer renders that. And so that's one of the reasons there's a difference between them. Is, at least traditionally, JavaScript was a language that you only ran inside of a website. It only ran in a web browser, and that's the only place that you ever ran any of your JavaScript code. The backends were all other languages. In fact, at first, and maybe they'll talk about some of this, this is probably going deeper into stuff than we need right now. But at first, on the web, there was no JavaScript at all. It was just HTML. Oh, here we go, client side versus server side. So it was just a server that was figuring out what files to send you, and maybe even generating those files, the HTML, for example, and just sending it to your browser to render. And so it was pretty much just this concept of almost text files is being sent to your computer. And then they've got markup to link to other text files, right? And that was a whole bunch of different languages that were used on the back end then. Java, Perl, CGI, PHP, C#, a ton of stuff that was used to do that. And those were C, C++, really any language that people were already comfortable with, they started building out websites with. Then eventually it was actually the precursor to Firefox, but Mozilla, their browser and the precursor to all that, Netscape, that was where the guy who created JavaScript worked. And they said, oh, we want to be able to embed something in the browser to have some interactivity. And this was actually competing because there was something which was called like Java, I'm going to get the name wrong because this is the reason it ended up being called JavaScript. But there were essentially browsers were embedding their own Java engine as well at that time. And so you could push Java code up, not JavaScript, and run it, except it was very kludgy and sort of slow. And I don't know if anybody's ever encountered those. But Java servlets, I think, I can't remember. But that's when JavaScript was created as something to be like built into the web browser and work. And Netscape was the first one to sort of build that in. And then it just sort of built up from there in terms of functionality, where it gave you some basic things like, oh, we can handle clicks and maybe do some logic, add some nice animations or other things. ECMAScript was the name that came about later when the standards body got their hands on it. It is technically, the language technically is called ECMAScript as a standard. So if you're looking for like the JavaScript standard, if I were to Google that, like, then no, I don't want the standard. You'll notice here, one of these links is ECMAS 262. And that's because ECMAScript is the actual name for the standard of JavaScript, but nobody calls it that in practice, although we're going to encounter a legacy of that in class today, so it's sort of relevant. Originally, I think it was called like Oak Script or something, is what Brandon Ike wanted to call it. And Netscape was like, no, we want to piggyback off the popularity of Java. Let's call it JavaScript so that we can steal some of that naming popularity, because Java was like taking over the world at the time. Everything's going to run Java. Nothing's ever going to run anything else. And so they sort of hijacked some of that, and that's where the name came from. And unfortunately, that's why, it gets confusing. So let's see. I'm going to look at just a little bit more of this because I think it's a relevant question. Let's see how much this talks about it. So remember this: client side, HTML, CSS. Oh, it's got a little more. Server side. We'll get into that stuff later. The server, to talk a little bit more about some of this, is like the server is where your database is going to live. So if you need to get data out of a database, you need some sort of server-side code to do that. You need to go back to the server and figure out how to fetch that stuff. The server is where, when you make what are like API calls or fetching more data, that's where all of that stuff comes from. And traditionally, as I was saying, there was no JavaScript running on the server. So the introduction of that really came about with Node.js, which I think was, 2008, 2009, I think was when it came about. So it's still pretty new. It's amazing that it's so popular on the back end. But that's when people said, oh, wait a minute, if we're writing JavaScript on the front end, why not write it on the back end too? And then we can just use this same language everywhere versus having this big divide between them. And that's why, that's why some people say like it's taking over everywhere, because if you know JavaScript, you can write on both ends. Whereas if you know just like C# or something, well, you're going to have to, if you want to have really dynamic interaction on the front end, you're probably going to need some JavaScript at some point. Yeah. Well, we can go over these. I'll steal from these and make a more condensed version in the future, because there's some, if people haven't been there, Girls Develop It has some great introductions to different topics. So it's some fantastic notes. But I want to do let's make sure people are online. Let me know if you're seeing the stream. Just speak up and say you're seeing it. Like to see that. I didn't get to it today, but I am going to work on seeing if we can get some more controls up when you guys are on. I can pull up a chat window, but I don't know if that stuff will show up on any other screens for me. Let me see. I'll take a quick check. I just don't have anything that's going to make it easy to show something. Oh, you guys are seeing me instead of my screen as well. All right, there we go. All right, so today let's talk about modules. And this is going to be probably a short talk and then some hands-on time. We'll work through some pretty basic stuff and then maybe try and work through another coding exercise, but using some modules to help us solve it. I don't have one off the top of my head. Maybe we'll try and steal one of the ones that we've already talked about, or maybe we'll come up with something else. So we haven't really written very large chunks of code yet. We've written pretty small things, but if you remember, we talked about how large code can get, right? Like Microsoft is millions of lines of code for Windows. Google's the same. Or even by the time you're getting to thousands of lines of code, can you imagine trying to put thousands of lines of code in one file and find what you're looking for, being able to figure out how to keep stuff together logically in that file, right? It would be really, really hard to manage stuff that way, but that's all we've done so far. It's gonna be hard to figure out where's the functionality that I'm looking for. It makes it really hard to collaborate since anyone that you wanna work with is working in the same file. Oh, I have to work on that file right now. Okay, well, I'll work on it later when you're done, right? So if your files get large, then you're gonna have a problem collaborating. It makes it really challenging to run different pieces of functionality by themselves, such as, oh, do I have this? Oh, there, to test them by themselves, or like we were doing in the last class, we wrote those unit tests, right? And they were all in the same file that we were writing the actual code in, which means when we ran it, we ran the tests in that file. But what if we don't want to run the tests every time we run our zip function? You know, we want to be able to only run those sometimes. Well, we could put a whole bunch of extra code in maybe to say, oh, here's some flags, you know, if I pass these values in when I run this, then execute these functions or other stuff, but that'd be really cumbersome to put in. So we have a system for that. In other languages, they've always had it, or it's sort of been baked in. But we've got JavaScript modules that'll help rescue us from this and be able to create some of this structure and separation that we need. So what do we get by having modules? And a module is just the concept of being able to split stuff out into different files, different folders, create some structure around your code. Here's some of the big benefits that you get from thinking about stuff in a modular fashion. You get encapsulation. And we'll highlight this a little more, but you'll notice all of these are terms that we've already talked about for the most part in class at some point, where modules help us leverage these high-level concepts in a very practical way. So any good module system lets you hide access to module internals, such as variables. And what I mean by hide access is something outside of that module isn't going to have access to it or be able to read those values at all. There's something that is just inaccessible to them. And that way, there's a great saying I heard at development talk several years ago that I sort of internalized. And not necessarily encouraging it just as people are learning, but it was, programs are messy in the small and like clean in the big, or coding is. And so what you can think is that, you know, when you're inside of like a function, for example, that's a encapsulation bit of logic. You may have some really ugly code in there to accomplish something, but you may make it look nice and clean by having a nice function name that somebody can call, and you hit all of that, right? Modules help you do the same thing. You can hide some ugly stuff underneath the covers with encapsulation. And related to that, you've got abstraction, right? This is not so much like preventing people from accessing stuff. That's really what encapsulation is about, is, oh, you can't see this variable, you can't access it. Abstraction is the idea that you get to work at this higher level. You get to think about what you're working with in these large building blocks, these large pieces, as opposed to working with the individual variables. And modules help you do that because you can think a lot of times of a module or a library as this higher level thing that you're working with, as opposed to at an individual level. You get reusability. You get to reuse modules repeatedly in a single project, and you get to reuse modules between projects. And that's really what we're going to focus on in the next class, is how you pull in other modules, how you make, I don't know if we'll necessarily export our own to the NPM registry, but we'll be pulling in other modules that other people have written, which allows us to reuse their code in our code instead of having to write it ourselves. And you get separation of concerns, right? We talked about, oh, if you've got multiple people working in the file, how can you all change these different areas without stepping on each other? Well, if you've got modules in the sense of separate files, then different people can work on different modules. You may not even have access to the internals of that module at all. It may be a team that owns that chunk of the code and says, oh yeah, we'll give you that access. And maybe another team says, oh, we really need to, I don't know, a team that owns a module to access the database, right? And they say, oh, we really need to be able to get a count of all the users easily. Yeah, we can like retrieve all the users and then count it ourselves, but it'd be really nice if you could do that. And the team that owns the database access might say, okay, yeah, no problem. We will add another function, another something for you to call that's just, you know, users count. And then you'll be able to call that. And you don't have to worry about how that's handled. And we can build that out. We can just make it available to you without you guys having to actually do that logic yourself. So a module system buys us a lot of nice things. But we got a problem, and that is that JavaScript did not have a module system originally. We were just talking about when JavaScript was invented. I don't know if I mentioned it before, but JavaScript was written originally in I think like 8 or 9 days. And the core of the language as it is today, pretty much everything that we've really taught in this class was there or very close to what we've taught at the end of those 8 or 9 days, right? This was something that they were trying to get out incredibly fast. They really wanted to get something on the market. And so that's also why there's some awkward, you know, bugs. I wouldn't say bugs, but, you know, just rough edges to the language, things that are really weird about it. And one of the things that it never had was a module system. It wasn't thought of as something that was going to necessarily scale to the size that it was today, right? JavaScript was something to add little enhancements to your web page. Oh, when you click on a button, do something. Oh, add some animation here, add some effect, do a pop-up to tell people that, you know, they need to, the password isn't correct. But now we've got huge programs, huge things running in the browser, and so we've needed to sort of introduce one over time. Yeah, originally code could be split up between files, and you could load multiple files in a web page, but the problem was that everything in those files lived in the same global scope. Mind you, if you declared variables inside of a function, they were still in the function scope, but all the functions or any variable that wasn't in a function was all in one scope. It didn't matter if they were in separate files or not. And this could cause all sorts of awkward problems, right? So if 2 different files declared variables or functions with the same name, then whichever one gets loaded second and processed second wins. It doesn't matter what the other one had because they're living in that same scope, that same namespace. There's no way for them to be separate from each other, right? And that's another reason that module systems are really important, is to create these scopes and namespaces so that you don't have global collisions, so that every single function ever written by somebody doesn't have to have a unique name from every other function, so that I can teach you guys to write hello world as a function, and I don't have to say, oh, yours has to be hello world, choose a random number of 30 digits to put on there, right? Having modules allows us to avoid those sorts of complications. So, enter JavaScript module systems. The JavaScript community recognized this problem and created solutions for it, which is awesome. And we're not gonna go into the full history of these different module systems that have been created. It started with the idea of things like immediately invoke function expressions, which are a really cool little thing that you can do in JavaScript. Maybe I can show people if they want to see it later, but they're a way to simulate all sorts of really cool things. Like if you're used to classic object-oriented programming with private variables and public variables, you can use an immediately invoked function expression to do the same thing in a language like JavaScript, and you don't have to have these top-level concepts for it. But then we had actual module syntaxes or module standards that were created. That included the asynchronous module definition, which allowed modules to be loaded asynchronously, included CommonJS modules, which are the ones that really spawned with the Node.js backend at the same time, which is awesome. But the different module systems created didn't work with each other. So if you created modules in AMD syntax, you couldn't use them in a CommonJS file. If you created CommonJS ones, you couldn't use them in an AMD module system. Also, the browser didn't have anything to load these modules natively. So if you wanted to use any of these, you had to either compile the module bit out, like pre-build your code so that it got rid of that, or you had to have maybe an extra file in the browser that understood this. And that, for like the AMD one, there's a required JS file that you would run in your browser so it would know how to deal with all the modules. And really, in that case, the modules are just a wrapper, a complex version of these immediately invoked function expressions. That's what AMD modules really are. And then the required JS bit can help it figure out how to work with those. So eventually, with the introduction of ES6, and you were talking about ECMAScript, that's why it's called ES, that's short for ECMAScript. And this was standardized around 2016, 2015, 16 is when this was ratified. And this was probably the biggest change to the JavaScript programming language ever. And we're going to be talking more about some of the things introduced with ES6 in our future classes, because there's a whole bunch of new syntax that I've intentionally avoided up till now because I wanted to have you guys using more core JavaScript syntax, but I need to introduce it before we get into React. Yes?
ES6, when they started introducing like classes?
Yes, ES6 also introduced, well, yeah, ES6 introduced the concept of classes, yes. Now, again, I'll say this, be careful thinking about classes in JavaScript as the same. We're going to use them in our React stuff, but be careful thinking about them as the same thing as classes in other languages, because they're really a wrapper around the way JavaScript objects work, which is prototypical inheritance. And so anyone who's familiar with classical inheritance can get really tripped up if they're thinking that they're the same. Honestly, if it was me, I really regret the introduction of classes. I think it was a mistake. It was put in there to make people feel warm and fuzzy when they came from like C# and Java. I'm like, oh, I feel all warm and fuzzy because they kept creating their own class version in different libraries. So like the Dojo library had classes that had been done, and every time somebody came from one of those languages, they're like, oh, just make classes. And really all it's doing is taking JavaScript objects and taking away some of their really cool abilities and dumbing it down to what those other languages support, which is a shame. So ES6 modules were introduced with ECMAScript 6, which is awesome. Yay, it's all good. We've got a standard module format. We don't have to deal with these other problems. Except the Cloud9 system you're working on uses an older version of Node.js, which hasn't yet added support for ECMAScript 6 modules. It only still supports CommonJS modules. So for today, we're going to be working with CommonJS modules. That's not a big deal. Later we'll go over ES6 modules because we're going to be using some tools that work with those. And most browsers actually support ES6 modules now, I think. As of like the last year, almost all of them support them in some way. But we're still going to use something that hides some of that detail. But the concepts are pretty much the same between these two. So it's not that big of a deal that we're using CommonJS. As long as you get the concepts, you'll be able to translate them when we go to the ES6 modules. Any questions on that? All right. We're almost done with slides, and then we're going to do some just working some hands-on stuff with modules. So CommonJS, let's talk a little bit about this. In CommonJS and ES6 modules, each file is a separate module. So every file that you write is going to be its own module, and by default, anything declared in that file is only accessible within that file. So other files can't access the contents of one file, and we'll see this. I'm gonna do all of this sort of hands-on instead of just doing the slides for it. So I'm gonna try and work through what all of this means. Questions about that yet? All right, so the two basic elements of CommonJS modules are require and exports. These are the things that are actually worth trying to remember. Again, we'll see this, we're gonna work through this, but require is a function, I should have mentioned that on here, and it's used to include other modules in a file. So that's how you pull in a module into a file. And exports is used to export code from a module so that other files can use that code. And I will switch over to hands-on examples to sort of talk about how this stuff works and what this means. Before we get into the code, any questions about this so far? All right, let's see what we got here. Okay, I'm gonna need to do some zooming. Close that. Not be too much. So I'm gonna start with something very, very simple. And you would never actually do something like this, but I just wanna show you the most basic sort of module integration, right? Let's create a hello.js file. We've done this before. This is trivial. This is like one line. All right, we've got a hello, and we can run that, right? We can run this file, and we get to see the output. It's great. But if I'm going to be using this app.js file as our sort of common file throughout the class today, unless there's a need to spin up another one. So how do we access another file inside of a file, right? What I said was there's a require function, and that's built into Node. Node's going to understand how to interpret this require function and how to connect these files when it's running. So this is stuff that it's put on top of JavaScript. This wouldn't work in a browser directly. You'd have to do some other work to make something like this work in a browser. But what you do is you just require the other file you want. Now, the one sort of trick here is you need to tell it where in the file system it is. If it's not, we'll talk about it a little more with NPM, but if it's one of your own files, you need to tell it where to find it relative to the file that you're running. So if we look at mine right now, the app.js file is in the same folder. It's at the same level as hello.js. And so since they're sitting at that same level, the way you say this directory is with a // and then I need to do hello.js. So this is me importing the hello file in my app file. I'm going to comment this out for a second before. I forgot I wanted to show you this. So I've got this app.js file. Let's run that. And we see nothing, right? Which is what we expect. There's no code in there. There's nothing for it to output. There shouldn't be a big surprise with that. And now if I import the hello.js file and I run app.js, I see greetings, my excellent friends. What are we laughing about? So what that tells me is by doing this require, it ran the code in this other file. Right? That tells me that the code in this other file executed, but it didn't really give me much. I didn't get much use out of this yet, right? What does that allow me to do? So let's try some other things. I talked about the exports, right? So instead now, I'm going to change this a little bit. Oh, I should have left that. I'll leave a console log. I'll leave it there, even though, again, I told you never to do this. Never put a console log inside of a function. But we're going to make our old standard say hello function. So now our hello.js has a function in it, right? Just say hello. And app.js is still requiring it. And if we run hello.js, it doesn't print anything out, right? That's expected. We're not calling the function. So what that means is if we run app.js, we're also not going to print anything out because we're not calling the function. It's not being called anywhere, right? So how can I call that function? Well, let's try this. Let's see if we can just call it here. Say hello. After all, we required this module. Does that work? We've got an error, and it says, or it's a reference error, say hello is not defined. So it doesn't exist in this context. It's not there. And that's because we didn't export it from this file, and we didn't properly reference it over here either. So what you need to do, if I want this to be accessible out of this module, outside of this module, I need to put it on my exports. The export is just really an object, and then I can say what I want to export stuff as. So I'm going to say, I'm going to add a property to my object here, just say hello, and I'm going to assign it to be equal to my say hello function that I have up above. So now this file is exporting a say hello variable off of it, which just refers to this. But I need to be able to get that say hello off of what I required. So what I need to do here is I need to get a reference to this exports object, which is basically what this is here, is a reference to that exports object as a whole. And now let's try this, and we should fail. You guys should see that this blows up because it says hello is not a function. And it's because I said it's a reference to the object, so I need to refer to the property on the object, just like I would have normally. And now I can call that method, that function, that property on my object in my other file. Does this make sense? Any questions?
You would want to do this with somebody else to work on it, or this is your own file? You would want information in both files to do different things in the files?
Yeah, I'll get to some examples, real world, in just a moment of where this begins to show its value, and hopefully it'll make sense. And then maybe I do have some idea for something we could work, but I don't know if I'd be successful. Maybe it'd be good to see me completely fail at trying to do something. Or someone can come up with another, if someone's got an interesting problem that's not too hard, but the step above the stuff that we've done before that we could work on to try and split some stuff up, I'm willing to tackle something. Yes, Matt?
In addition to writing your own modules, is JavaScript able to bring out modules that other people have written?
Yeah, we're going to focus on that a lot in the next class. So, but I can give a little bit of a conversation there. For the most part, and it's sort of nice that we've at least standardized a little bit. For the most part, the JavaScript community has standardized on, especially the Node community, on modules being able to come in from this npm package manager. So this is a website. This tool gets installed when Node gets installed on a system. So any system that has Node almost always has the npm utility as well. And npm is sort of like several things. It's packages, and it's a tool, a utility in your computer, etc. But there are, maybe they don't show it anymore. They used to show account. Let me see if I can find it. Module count, maybe. Let's see here. They used to sort of show this stuff off. Oh, that's not very pretty. Do they have a stats? Do they have a- Yeah, I know. I was just looking for something that was a little more. It used to have like a stats page, I think. Let's see if it still exists. Oh, that's an actual library. So if you're looking at this, this is a little hard to see, sort of tiny here, but these are different module packages for different languages. Like this is Perl, and this is .NET, and this is NPM. There are over 800,000 packages available through NPM. So it is an incredibly popular, by far the most used package repository for any programming language. And it's just about anything out there. So, you know, we're going to talk about how to leverage some of this stuff in the next class. But if you want to have fun in between there, I would definitely encourage people. And post stuff in Slack. Go do this and have fun with this. I really encourage you. But think about something that you think it would be cool to be able to leverage to pull in. I mean, there's a good chance that you're going to be able to find something. I don't even know. Let's see. Is there like a Pac-Man? Animate a progress bar with Pac-Man game. Somebody's got some stuff there that tells you how to animate a progress bar in your web browser as a Pac-Man game. Here's one that's a whole Pac-Man game written as a React component. And it's even got a tiny bit of code that sort of shows you how to work with that and pull it into something. There's ones that are just backend that are really fun to play with, like I think it's right. Cowsay, you know, and there's here, let me. This is me actually pulling it down to, I think this will work. Let's see if this works. Actually pulling down the module and running it right there all at once. That npx utility I don't think exists in the Cloud9 environment either because it came with a newer version of Node. But boom, I just ran a little bit of, I just pulled a module down, it runs here and does something, you know, fun. Another one that's like that. I think this is the right naming for it. Let's see. So there you go, yeah. There are, I mean, go have fun. Go play around on here and look up stuff. You can say, oh, I'm really interested in, and maybe there's something you're interested in trying out, right? Maybe you want to look for Easter eggs, like, oh, I want to add some Easter eggs to a website or something. Oh, maybe there's something I can pull in that I can leverage. Maybe you're interested in, I mean, there's packages for just about everything. So yeah, it's very possible to go leverage someone else's packages and work with them. And that's what we're going to start talking about, because when here, let me try and open that back up. When we start working in, say, React is a package that we're going to go pull down from here and work with. So we're going to work with a whole bunch of packages coming out of this ecosystem that aren't ours. And you can see, it'll even give you statistics, like React itself is downloaded 5.5 million times a week from this NPM repository. So that gets used a lot. A week. Yes.
How is that possible? There's not many programmers.
Well, there's a habit in the NPM ecosystem where you pull down, a lot of times they'll pull down the package like every time they do a build instead of just pulling it down and leaving it locally. So if somebody's building like on their system like 20 times a day, for their project, that's 20 pull downs of that package frequently. So there's a lot of people who do that. I don't know if it's the best practice, but it's pretty common. So that's why the number is so crazy high. It's sort of a bad habit of the Node NPM ecosystem. To give a horror story related to that a while back, about 2.5, 3 years ago, somebody who had packages up in the NPM ecosystem decided to pull them down, and they don't let people do this anymore because they weren't saving local copies of the packages and using them. They were fetching them from NPM every time, right? And it was a silly utility. It was called leftpad. All it did was add white space characters to the left side of a string. And people were pulling down a package to do this instead of writing their own code to do it, which maybe that's a good exercise. Write a leftpad function. It takes a string and a number, and it adds that many spaces to the left side of the string and returns it, right? But people were relying on this package, and some core other packages were relying on it. And when the guy decided to pull his packages, because he was like, I'm just done with all this, it broke major websites for a day because their builds just couldn't run because they were trying to go fetch this package. It wasn't there, and their builds were just failing, and everyone was freaking out. Oh my gosh, it blew up the front end community. They were like, oh, this is awful. Of course, we didn't learn a lesson, as you can see, but
So I'm encouraged you guys to make use of tools like this so that you're waiting for it. It's never want to reinvent the wheel. If someone has already done something and not that. I mean, maybe not for something as simple as adding a string. But I would say there are things that they're so complicated that it would take you years to deliver. And so using code that other people are running here is one of the primary things that programmers do with open source languages like JavaScript. So make sure before trying to do something yourself from scratch, make sure it doesn't make it.
yeah, unless you're using it as a learning exercise.
Right. Unless you have a homework assignment.
That's the challenge with teaching people stuff nowadays, because 20 years ago, there weren't these repositories that people could just go fetch everything from. So teachers could give people the same assignment over and over, and they'd rewrite it. And now people are like, why don't I just go pull this thing down? Like, well, you're trying to teach you how to do this, not to go pull someone else's code down and use it, right?
I think that learning is changing now. Memorizing things off the top of your head, memorizing lines of poetry or facts from history or whatever is a sort of useless skill in the modern environment where you can just use tools to find stuff like that. It's more about synthesizing information, interpreting it, rather than just like collecting a bunch of gaps in your head.
Right.
So I think in programming has sort of changed analogously. It's not, it's still important to have good logic and reasoning skills to build good code, but another important programming is just knowing how to find and use modules.
Yeah. Yeah, I strongly agree. Yeah, programming isn't about just memorizing stuff anymore. And there's a lot of programmers who used to be really good at that, and that's not something that you really need to do. And I think you'll notice if you think about the way that I've talked about stuff in class is I haven't emphasized, we haven't gone through massive lists of things to memorize. I haven't talked to you about here's all the functions available for a string. Here's everything that you can do in an array, right? So I've told you to go find those things yourself and go look these tools up. And the reason for that is because it's much more important to do that. Instead, we focused on, here's the way to think about building a program. Here's the thought processes you can use to build something out, because those will apply. And then you can go, plug in the small individual bits with Google or pull in a library to accomplish something if possible.
I have a question.
Yes.
So what's the difference between require and import?
Yeah, import is that's part of the ES6 module syntax. So we're going to talk about that, but we're not going to do it right now because anyone working in Cloud 9, it would not work in their Node JS that's installed on the system without me trying to have people upgrade Node.js and stuff. And I don't want to have people struggling with that right now.
But is it like a similar function?
Yeah, it's the same sort of thing. I mean, not to get into it too much, but if I were to rewrite these two using import, like the export and import ES6 modules, which again, this is not the way that we're doing stuff right now. But let's say I did rewrite them. All I would change here is instead of exports.sayHello, it would be export say hello. So you'll notice it's already yelling at me. It doesn't like that. That should be correct, I think. I could say default. Let me see. Oh, then it's happy. So I must have something else. See, I don't do this stuff necessarily every day. Let's see. Oh yeah, that's right. It's a little weird. With a function like this, here, I'm gonna go back to what it was. Usually on a function like this, you put the export right here, or it ends up looking very much like this was. It's like export, what is the syntax? Oh yeah, when you do something like this, it ends up being like export and then like an object where it's like say hello equals say hello. Syntax something like that, I believe. I don't know. Double check. It's funny is those are the modules I write all the time, so I just don't do a lot of exporting. I'm usually working inside of stuff, so I usually search it up when I'm writing a module.
Is, coming off to what you said, isn't there also like include as well, or is that not JavaScript?
Include is Python, usually the Python method of pulling something in. In JavaScript, if you were to, what did I have wrong with that export? Let me double check. Oh, okay. When I did the other version, I just had it a little off. So you can only have, the reason it was complaining is when you export something like that, you need to, you can only have one export really. And then I think you're only allowed to refer to, you don't say like, this is my object. It's just uses this sort of object syntax and it's just a reference to everything you're exporting. So that's the syntax if you're doing it like that. Or you can do it right on the line here, like export, like I said. There are default exports as well. I'm going to focus just on named exports here, but there's the ability to default export stuff from a file, which you'll definitely encounter at times. I just think named exports are it's just nicer to stick with one or the other, and named exports allow you to, they're more flexible and easier to follow what's going on versus default ones, so. Yes?
So is it better to say I import something from GitHub to you, or you export something from GitHub from my file? When they about the same, doesn't matter.
No, it has to be both. It's not one or the other. Because you'll notice, see what's going on here, right? This guy is exporting say hello. And all that's doing is making this accessible, but it's still only accessible in this file. There's no one else who's going to, or in this folder structure, this project, there's no one else outside of this is going to have access. And then this has, essentially this requires an import. This is importing it into this file. So you need to do both because the export is just a way of saying like, oh, other people can use this out of me. And then import is a way of saying, I want to use that. Right? And we could write another file instead. We have app.js. I could write an index.js, and that gets to this reusability bit. And because I'm incredibly lazy, I'm just going to copy this over here. But now I'm using that same export in two different places. And that gets to that code reuse bit as well, right? So let's say now we want to change the greeting. I don't know what we're going to say. This isn't really a greeting, but throw back to one of my favorite cartoons. And if we call index.js, it's got that. And if we call app.js, it's also the same thing. Right? And that's because those are referencing the export from this dynamically and checking it. So we were able to change the functionality in both of those other files by changing this one file. That's that sort of being able to reuse something, being able to share that logic. Yeah.
Could you kind of change the logic from different files? So let's say if you want to have like a completely different logic from index.js from app.js, to do that. So like instead of saying like, what are you thinking when I'm thinking, you change it to like, you are thinking to what I'm thinking.
I mean, you would need to pass in, so you can't easily do it just based off the file, like, because this hello.js isn't going to know what's calling it and where it's being used. So the way you would do that, the way you pass information at all, is you add a parameter, right? So if we did that, you wouldn't be changing it for one file, but you could add a parameter to say hello, right? Which could be, I don't know, is question, right? And if it's not a question, like, then we could have some logic in here to deal with that. But you can't really have it be different in one file or another based off the file that pulled it in, because that would involve, you wouldn't want to do that anyways. And this gets into some of the stuff that is more learned by experience than something that you're going to realize right away. But what you'll hear a lot of language thrown around about module systems and how you want to build this stuff out. But what you want to have is tight cohesion between stuff in one file. And what that means is any of the code in a given file should logically, it should make sense that they're together. But then you want to have loose coupling between different files or different modules. So you don't want them tightly bound, right? And so if, for example, this could say, oh, when I'm called from index.js, return this, and when I'm called from app.js, return something else. Then what you've done is create a very, very tight coupling, because this hello.js is no longer generic and reusable by anyone. He's tightly coupled to app.js and index.js, even though there's really no strong benefit to having done that. And so you want to try and keep coupling like that low if possible. And that you do that by doing things like having parameters that, oh, the guy who's calling can always pass a parameter as needed. And this one doesn't need to know what's calling me. He just knows, here's my different options. And that gets into some really like things that you sort of learn over time about the dangers of having that sort of coupling. Is when you end up doing that, then you're not gaining a lot of benefits from having the stuff in separate files, because you end up having to change them all at the same time. The goal would be, if you have to make a change, that you're not having to change every file in your project, that it can be somewhat isolated. And so that helps. That's a way to help think about like where modules should be. Now, of course, that isn't true when you're talking about like, oh, the function signature, the parameters that the function takes changed. Well, now every file that calls it needs to change too. Okay, that's understandable, but that's a good question. That was a good thought. You have thoughts right now? We're having a lot of talk around this. I mean, keep asking questions about this stuff. We're going to build out a little more, but it's going to be focused probably more on how this stuff works and what it means to your code in terms of having these modules, right? So now let's highlight some of this other stuff I was talking about in terms of the encapsulation, being able to hide something. So we already sort of saw that. Remember, before we exported say hello, it wasn't accessible. We couldn't call it in app.js, right? It didn't work. So for example, if we create another function And because I'm very uncreative, we'll do just say goodbye. I don't want to do that. What should I just say? Bonjour. That's hello, right? What?
Adios.
Adios. Let's go with adios, right? Something simple. You know, we can't call that in here. Hello is the name of this module. We can't call say goodbye because we didn't export it, right? So it's going to fail. But that doesn't mean that it's not accessible in here. We can call it in here. And if this whole module is going to run, although not the code inside of the functions, because just like functions that we've declared elsewhere, the function doesn't run when it gets evaluated. It just gets evaluated and stored, right? So we need to invoke it here. And now we will see our say goodbye printed out, even though if we tried to call it an app.js, it would blow up, right? So that's that concept of encapsulation. So let's say, for example, we have something a little more complicated here. We're going to change this to say something. And what should I do? We'll take in a number. I'm just being very lazy here to do this. Yeah, this isn't necessarily good code, but then what I'm going to do, I'm going to steal this and move it down here. This is just sort of showing you how you can encapsulate some logic, right? Slide this down, let me get rid of this, give us more space. And up here, we could have some say, oh, when they passed in 0, let's just say hello. And that's what we'll call. Otherwise, we'll call say question, right? Now, if we try and call this, do I have that backwards? Something's wrong, just a minute. Oh, because I'm exporting say hello here. All right, I'm gonna be lazy here. I shouldn't do this. I'm not gonna do that. I don't wanna mess you guys up. I'm gonna change this to say something, right? Now, when I run my code, it should fail because it tried to call say hello, but say hello is encapsulated. I don't have access to it in app.js. So I need to call say something instead, which I do have access to because that got exported. And now I'll get, are you thinking what I'm thinking? Or if I pass in 0, I'll get hello, because those are my 2 paths that it can take. But it can't call either of these directly because those are hidden. Those are encapsulated in this module. So that's a way to protect or write a whole bunch of extra stuff that you don't necessarily need to expose. Oh, I've got all these nice utility functions that help me compute something. I can put them in my module, put them in this file, and then export something else instead of all those low utility functions. Yes.
I'll give you just, instead of just like grabbing each one, because I'm like, in my head, the only way I can see if I'm doing it is like, let's say, I want to have access to every single function. And is there an easier way instead of just doing exports dot same question and then equals that?
Not really.
Really? Okay.
Part of the reason for that is you shouldn't have that many functions in one file.
Okay.
Right? Some people take it to an extreme and say one function per file when they're writing stuff this way. I think that's pushing it pretty far. But you'll definitely hear a lot of different opinions on like what a good function length is or how many you should have. And a lot of times you want to keep the number really small. So you shouldn't be doing like hundreds or dozens for the most part. You should be doing a much smaller number than that. And I lied, there are ways you could automate some of that, but it would get pretty complicated to try to handle that export layer.
I keep going back to this right now. But I think the way I think about this is like modules are sort of like paragraphs. You think about your whole composition of paper. Modules are sort of like paragraphs, sort of like blocks that make up for your work. And so while it'd probably be ridiculous to have one sentence per paragraph, like one function per file, you also don't want to have, like, it would be an insane paragraph to have one sentence. Just like not organizing your thoughts very correctly. So the same thing for these types of modules is that a handful is fine, but they should be organized and connected in some logical way. No one just look at 5 random files, 5 random functions in the same file.
Right. I love that analogy because it fits so much of that logic, right? So for the people who are remote, the analogy was talking about thinking of modules almost like paragraphs if you're writing a paper, right? A paragraph is, it's a connected piece of logic, just like a module should be. It should be shared logic. It should all be related, but you also don't want it to be huge, right? You don't want one paragraph that's 100 sentences. If you think of, say, a function as a sentence, you don't want it to be that way because that's too long. You want to have it be contained enough to work with. And going all the way down to a sentence, if you think of a function as a sentence, you don't want a sentence that's too long, right? Just like you want to make smaller functions so that you can work with these things, these building blocks. As you see them begin to grow to a larger size, you should start saying, can I make this simpler, right? Can I split this out in a way that works effectively? Good questions. So let me show a more useful example, although you wouldn't necessarily write this exactly, but let's try and show a more useful example of what you could do with encapsulation in a module. I don't know how to spell this. We'll go with that. I'm going to create a file called incrementer.js. And in here, I'm going to you wouldn't do this normally. So it's not, this is just showing you why you could do something like this or some of the benefits you get from this encapsulation, right? And I'm going to make a function just called increment. And this is really simple. It's going to return the current count and then increment it and make it larger than it currently is. I'm going to export this from my file as well. So this gets into some interesting stuff. So I need to include this file, just like my other one. I feel like I spelled this wrong, I really do. But it's okay. Maybe it's just one of those words. I'm going to just log the results of it, calling it several times. And this begins to show you what you can do with some encapsulation when you're working with this stuff. You'll see that the output is an incrementing value. And that's because this module here that value is accessible to this function, but it's not accessible outside. And so we were able to create some, I mean, it's an interesting little sample, right? Again, it's not something you would usually be writing, but you can do stuff like this. There are some instances, some very unique instances where you want to leverage something like this. But this would also create some potential challenges, because it can get very confusing if multiple files that are all working together, like you'll stack layers on layers. In this case, we only have one, like app.js, but app.js may include a whole bunch of other files, and maybe some of those also need the incrementer, and they're also using it. And so then maybe when you increment in app.js, you don't get what you think you're getting because something else incremented in between. It depends on whether each require is a unique context for the file that it included, so it can get a little complicated when you do that. But those are some of the things you get with that sort of encapsulation, is you get to hide some of the details underneath the covers. So let's take this to a real practical example now. I shouldn't really have deleted that. But I don't like that stuff in there. So let's go over to a real practical example, do something a little different. And let's open up this zip that we were working with last time, right? This was our file that we had to be able to zip up, our function that we created to zip up two arrays, right? Which we can run and see the results of this. And we get to see that we passed all of our tests. It worked the way that we wanted. Everything looks good, right? But the problem is, what if I want to, like, the whole point of this zip function is to be able to use it in places, to be able to pull it into another file. Let's pull it into that app.js file that we have. Oh, but we can't right now. We need, okay, so that's cool. We'll export this guy. We'll just export it as zip here. I'm going to import it a little differently, but hopefully it's not that confusing. I'm going to do the require from zip.js, but instead of wanting to, remember, this is just an object at this point. It's the same as before. I'm going to get a direct reference to the function right now instead of having to do the dot notation later. So since this is an object here, I can get the dot. And so now this is a direct reference to the function, right? And now I could test this out, which is if I want to log the results of zipping to arrays, 1, 3, 5, and 2, 4, 6. I can do that, which is cool. Oh, I ran the wrong file. Let me see. Zip is not a function. Oh, I did not save this. See, I noticed the dot there. Try it now. Ah, there we go. We get to see it. But what is all this other garbage? Right? That's stuff that we don't want. We can't really reuse zip as we have it now, which sucks because we really want to be able to reuse this function in different places, but we also want to be able to test it. Ah, this is a perfect example of using modules in a very practical way. So what I'm going to do here is I'm going to, well, not on that. I'm going to create a new file. I'm going to call this ziptests.js. I'm going to go into this zip file that I already have and take all of these tests out of here. Now this file is really nice and clean, and I've moved all these tests over here into this zip tests file instead. Right? And now if I run my app.js, I get my zip without all the clutter. But of course, I haven't yet. There's no zip in here. Okay. We can fix that really easily. By just requiring my zip.js.zip in my test file. And now it runs my tests, and I can run my tests separately from the module that contains the logic. So I've taken those two things and split them in a way that makes it very easy for me to test it, very easy for me to have the functionality, but I don't have to have them live together in the same file. So that's an example of a really, really practical way to do things. And that's actually the way that most testing is done in JavaScript is you just have like a test file. A lot of times you'll do an extension maybe that's different, or it might just be like this, or they may live in a different folder, depending on how you want to do it. And then when you want to test stuff, you'll run your test files. And you may have a tool that helps you run tests. And that's why you may have them named a certain way, because you might be able to tell your tool, oh, run all of the files that are .test.js and just run every one of those and tell me if any of them failed, right? And then you can test all of the code that they want to test, but your tests are still separate from the actual code that you want to run when you're executing the code. That make sense? You follow that? Hopefully that was a good example of why you want to use a module system like this and the benefits you get, right? You took these two things, they're still connected, but you pulled them apart in a way where you can use them separately. That's taken longer than I expected to get to that point. Are there any questions right now about just working with modules?
Is there any way for someone to access a function that's not explicitly exported? The reason why I ask is because ours seems to be really designed. And then we can, in our module scale packages, you can actually access, they made it so that you can access functions that are not exported by the person that wrote the package. It's really weird. It's like, actually, it's like when you look up the help for that, it's like where you use the function at your own rate.
Yeah. I don't know. I don't think that there's any, there might be.
Probably shouldn't be allowed.
There might be some complicated way to do it, because under the covers, this is doing some complicated stuff. Like, let me see, where's
I
it?
guess so it's like, maybe the reason why it is like, there's a bug unexported function, then maybe you can use it as a way of debugging.
Yeah, I mean, something like that might be possible.
That would be weird, because like a lot of, so like in these open source things, like, that people use them. There should be like someone who
Thought I had something that showed what's actually happening, but maybe I got rid of it. Because what's actually going on is Node is sort of rewriting some like that, these lines of code, this require and the export. Node is actually wrapping up this whole file with some extra logic in order to turn it into a module when it notices all of that. And so if you know what's going on under the covers when it does that, you might be able to access it through those means, but it's not something that's necessarily exposed directly that way.
Or if you're writing a package, make sure you export all the things that you want.
Yeah, there is, there are default exports where you can export, like we used all named ones here, it would be like export.zip, but I could change this instead, and this is what I didn't talk about. If I do export.default, then that is, it changes this a little bit, where now if I reference this guy alone, I think this will work. Hope it will. Let me see. Zip is not a function. Let me double check here. See, I don't write CommonJS all the time. I think there's a reference to it in this, but this may not show it. Oh, module.exports. Okay, I wrote it wrong. Default is the ES6 version. Oh, it's just exports. Hold on. I think if I do this, now let me try it. I think, maybe not. See, maybe I have to do it with the full module dot syntax then.
Can you say module exports?
Yeah, the whole module thing is actually, the export should reference it as well, but it might not be. Oh, it does. Okay, so when you just do export, I guess you need to refer to it that way. So that's sort of like a default. That meant that instead of getting a like object out entirely, I gave it a default version of export. That does work. And I think you can still have named ones after that as well. And that's because of weird JavaScript capabilities, because a function can have properties. So a function can, we've talked about that before, a function can have methods of its own, because a function is an object, as weird as that is. Which is why you can both have a default that you can invoke as a function and properties off of it that you could pass as individual named ones. So I think that's the closest you could get. You can, like, you can export multiples and refer to them. This is using some newer syntax that's unsupported as well. CommonJS. Let's see. Yeah, there's not really a way to do it nicely. Yeah, this is what people use for testing. Is there's a whole package you can have that will basically actually, if you do a build of some kind to test stuff, it'll actually basically go into your file and change some of the code in a way that lets it access those things. So that's sort of the way you can cheat around some of that. But by default, there's not a way to accomplish that. But you can, in case it wasn't clear from this stuff, you can export multiple things from a file too, right? Like if we created another one and we have a math.js file, and we're going to create some functions here. Right? I mean, this is a little silly, but it's just an example of some stuff. You can export all of those. So it's possible to export all of those, and there might be a little bit of a shorthand you can use to do a multiple export. I'm gonna check real fast. Yeah, that's what I was thinking. It's not really that nice of a shorthand, but it's depending on how you like to write it. You could do like exports.add equals add and do that for all of them. Or you could write it, remember I'm saying that you're just creating an object there. So you could do module.exports equals, and then just an object literal, where it's like add, subtract, multiply, multiply. And then you're just exporting that object is your thing. And then you would have access to all of those. So if, you know, now our app file wants those. And there's probably a bug. I just wrote a ton of code, so we'll see if it can work. So you can have access. You can export multiple things from a file if it makes sense. Like in this case, that's a good example of stuff that makes sense together, right? Oh, I've got a nice little math library I want. Well, I can. Those are simple enough. I can put them all together in a file, export them. But this is really the way that this is the tool for scaling stuff. If people are familiar with other programming languages, you probably work with namespaces, or you know, Python has packages. I don't know if they're namespaces as well. But each programming language has something very similar to it in one way or another to be able to spread stuff out into different files. Any other questions?
Jared, I know we talked about this earlier, but where did you tell again when you have where do you tell again to export it to the app.js?
You don't. It doesn't know where it's exporting it.
Okay.
It has no knowledge about what's going to use it.
Okay, so you're just going to app.js and you're just like referring back to it to get it to do.
Yeah, app.js is going to it. It's like think of like I mean, this is I could come up with a lot of analogies, but think of when I don't know why this is what pops in my head. It doesn't seem like it's a great one, but you're in a gas station, right? And you go to the cooler section and you want to get a drink, right? Like those drinks are available for you to buy, but it's not like it had to say, oh, this drink is for Michelle, or this drink is for, you know, Connie, or anything like that. They don't have to be labeled, right? They just put them there and it's like, people can take them. That's what exporting is like. It's like, oh, this is available. Anyone can use this. I have no clue who's going to use it, but when somebody wants to, they can, as long as, that's what the CommonJS or Node is doing, is Node is doing all that hookup behind the scenes. So in the Node tool, when it sees this require, it says, oh, I know that there's a math.js file that I need to load and get the exports from. So that's where all of that binding is happening. And then it goes and loads the math.js file. It grabs the exports, creates this object, and assigns it to this math value here. So all of that magic happens at this line is when it actually occurs. In here, all it's doing is saying, when you come and read me, this is what's going to be available. This is the line that does all of the actual work. Does that make sense?
So if you can you do like the subtract there on the same line? So you only import the subtract.
Yeah, I could. I could do a dot subtract, and then like if I change this, I could rename it to subtract. I could call it math, but what we'll see is like all of this is going to fail because there's no math add. And there won't be a math subtract either, although we didn't get there. So I'll get rid of the add, and we'll see that we blow up at subtract, and it says there's not a math.subtract. And that's because we named subtract math when we imported it. Because we really changed the name of it. We were like, oh, this subtract function is now called math over here.
Basically, it's only math. So if you only do math without the subtract, it would work as subtract.
Yes, if I did that, and I'm going to get rid of this line because I know it'll fail, then it will work. Yep. So you can directly get, that's what we're doing with this .zip too, is we're getting a reference to just an individual method on the zip object that got exported.
And you have to write, if you want to get multiple functions, basically you have to write them all on separate lines, right? Can't you just like get, for example, subtract and multiply, on the same line?
Well, you can. That's one of those syntaxes that I haven't introduced also because it won't work in the version of Node.js that's in Cloud 9. But I can show you on my system because the version of Node I have works. So there's what's known as object destructuring. And that lets me do something really sort of crazy from a developer perspective. To you guys, it won't seem as crazy. To me, it's nuts that this works. Oops, hold on. I want to be lazy. This should work. You see here. Yeah. So this is actually a really, really complicated line. There's a ton going on here in the code, but it looks almost easy. It's sort of easy to understand. What it's saying is this is an object, and what I'm doing is taking that object, and I want to create 3 variables that point to 3 properties on this object with the same names as these variable names. So it assumes that these variable names exist on that object, and it assigns them to these things. That's like a super magical line code-wise.
Really nice.
It is really nice. It's another one of those things that was introduced. I don't even remember if that was ES6. That might have been one of the, now they do updates of JavaScript every year. That may have been one of the ones after. I can't remember. It is really nice, and we're definitely going to use it in our React class, but it's beyond what people need to be comfortable with right now. So right now, nope.
What if you call them different names?
Then your syntax is a little different. Oops, what did that do? Oh, I don't even know what I'm doing now. Get out of here. Oh, whoa. I've gone back too much. All right, you can call them different names too, but that's, what's the syntax for that? It gets a little different because it's like, I could do like subtract, add, or multiply, add, because really a JavaScript object is just a dictionary, so it doesn't matter what order. There's no order. Technically, there's no order to them. Oops, I got rid of the math up here. Something weird happened. So that should work just fine. But if you want to, this is where I'll get the syntax wrong. If you want to call them different names, you have to do something like this, like sub, and now it's like sub here, I think. So when you destructure, you can change the name, but you have to know what the name was and then like what the name is.
Makes sense, right? Because you are pulling it from some other file with that exact name.
Yeah. Well, any object. I mean, it doesn't even have to be from another file, right? This is well outside of what like class was about today. So people can feel free to zone out a little bit if they want. But I'll go back to just doing math here for a second. You can do object destructuring right from inside of like a file. So like if we did var, and we'll go back to our old like character type thing, right? I don't know, there's a cleric. And they're an elf, and their level is like 11 or something. So we've got an object there that we made. It's sort of weird, but right here I could do like class race level equals character. Oh, class isn't good, that's right. Yeah, role. I'll just call it a role. Right. And then I could always console log those out too. Like, that object destructuring stuff isn't bound to imports or exports. It's just about working with objects. So this is just creating variables off of this object, and all it did was, oh, I've got a character object, it has these things, I pulled them off, right? And if maybe it was missing one of them, then I actually don't know what's going to happen, but I'm going to guess that level will be undefined because it tries to reference, pull something off that's undefined. And yeah, so.
That saves a lot of time, right?
It is really handy when you're passing objects around and you want to reference specific portions of them. You can get just the bits that you need and not, yeah, it's a really, really handy bit of, it's just syntactic sugar. That just means it sweetens the language a little bit. It doesn't add any real functionality. It just makes it a little sweeter to work in. Any other questions about modules? Cool. We've already gone pretty long. So I don't have something specific on this to say like you need to go work on, but I would encourage you to go practice. Try to split up some of your files and maybe have an index file or I don't know, something else where you've exported some stuff from your existing functions and you call it in that file. So if you have, I'm sure for a lot of the exercises that you've done, if you have a file, you've both created the function and then called it inside of there. So maybe what you want to do is split that up into a test file versus the function, right? Give that just a little bit of practice, splitting those things up so that you can practice using modules in some way. Because next time we're going to start leveraging them more. We're going to pull in other modules and play with stuff from this NPM broader ecosystem and be able to start leveraging stuff outside of our own code. All right. All right. Oh, totally forgot. Shoot, I need to put a message. I'll put a message out. We are not having class here on Saturday. There's something going on. I can't remember. Daisy said it's unavailable completely. I think the whole AU or something here might be. I can't remember. So it's going to be remote on Saturday.
Oh, I get to listen to you and play PlayStation at the same time?
Oh man.